All right, hi everyone. My name is Joey Wilson. I'm a co-principal investigator for CS4 All Teachers, the virtual community that supports computer science teachers across the country. I'm excited to have one of our community ambassadors, Neil Plotnick, who is hosting this, along with our guest experts who will introduce themselves in a little bit. Just a few housekeeping issues. For this, we've got this really incredible webinar about robotics in the computer science classroom today with these wonderful guest experts, and we want you to be engaged in this. And so we want you to, if you have questions, we've got this chat box that's right here. This is a great way throughout the presentation to ask questions, to put comments in, to share resources that you have. And if you do want to speak directly to any of the panelists, you can just type in your question, and then I can unmute you at that point. So I'll be the person sort of on the back end managing all of that. And the one thing I just wanted to mention, so this webinar does showcase a few different tools. Because we're an NSF, a National Science Foundation funded research project, we don't evaluate or endorse any of the products, but we're excited to have everyone that's here on the panel. And with that, I will pass it over to Neil to get going. And I will turn off my webcam so it doesn't use up as much bandwidth for you all.
Oh, good evening, everybody who's dialed in, who'll be looking at this later. I'm really happy to get started with this project. The question came up with robotics in the classroom. It's one of my more exciting, I think, areas of computer science education right now, and there's a real wealth of different types of products that are available, different types of programming languages that are supported, and of course grade levels. There are people doing exciting things with robots from kindergarten up to grade 12 and then beyond. And I'm very happy that we have a couple of representatives, some of the leading companies in this area right now. We have from the people in we have people from Bambi Brewer, who's from the Birdbrain Technologies, and from Dexter we have John Cole, who's a founder of Dexter, and Lisa Rode, who is a Dexpert, who's been using the robots in some very interesting ways in the elementary school grades. So I'd like to continue with introduce everybody who's here tonight. Again, I'm Neil Plotnick. I teach at Everett High School, which is a school just located north of Boston. We have about 2,000 students, 6 different languages, and I've taught ECS, CSP, and this is my first year teaching robotics at the high school level. I guess next slide, Joey.
Okay, looks like I'm supposed to introduce myself now. Yeah, good. Neil's nodding. That's good. So I'm from Birdbrain Robotics. We're a small company based in Pittsburgh, Pennsylvania, and we are about 10 to 12 people, and we grew out of a spinoff from Carnegie Mellon University. So the products that we have were developed through NSF funding at the university, and the goal of that original product was to expand the representation of women in computer science by exploring a broader range of robotics options. So we've been a company since about 2011, so a little while and growing steadily. I've been with the company since 2015. So I was the first full-time employee besides Tom, our CEO. And I'm going to move to the next slide. I know I can't. I went to the preview where they taught me how to use all the buttons. So we make 2 products. The first product that we came out with was the Finch robot, and it is there on the right. So it is a small, you might argue that it looks a little more like a stingray than a finch. There is some room for interpretation there. And it's a small wheeled robot that's used in computer science from K to 12. So you can drive, its beak lights up, it has obstacle sensors and light sensors, and as well as an accelerometer. So it's used primarily by people who are teaching computer science. And we also make the Hummingbird robotics kit, which is different in that it does not come as a pre-constructed robot, but comes as a box of parts, and you add craft supplies to make the robot that you want. So I have some examples. You can have a little kitty here with felt. This one's hooked up. I have my robot flower here, so I can make it change the, change the color, make it bloom with the motor. So we have people build a lot of different things. You just get motors and lights and sensors in the box, and you build whatever you're interested in out of cardboard and craft supplies.
Awesome. Thank you. Thank you, Bambi. I guess we're moving on to John and Lisa.
Great. I'm John Cole. I founded Dexter Industries a little about 10 years ago. We're a really fun team that we engineer our robots and we support our robots. If you watch any of our videos, I'm probably the voice on the video. I'm an engineer. I love to talk to teachers and to students. I try to get into the classroom as much as I can. We build fun robots that are used in education and also used by professional engineers, sort of go everywhere from elementary school all the way up to Google. So Lisa is one of our Dexperts. She's joining us, and she's an amazing teacher that is taking the GoPiGo 3 and the Gigglebot to the classroom. I'll let her introduce herself.
So I'm a sixth grade teacher in an elementary school in Fairfax, Virginia. And I started with this Raspberry Pi and then really got into the GoPiGo, so using that.
Hey, Lisa, we can't hear you. Okay. I think Lisa's going to try to recall back in, and we'll have her introduce herself when she does that. Sorry about that. These are the downsides to webinars sometimes. And John, where are you based? You're because it looks like there's a lot of representation from your state.
Yeah, we're based out of I'm calling you from Arlington, Virginia, but we're a remote distributed team. So a couple of us work in Reston, Virginia, and we have engineers all over. So our CTO's in Montreal, and got an employee in China, and one in Michigan, and one in Europe. So we all come together via video conferences.
And Bambi, where are you based? Where did you say you're based?
We're based in Pittsburgh, Pennsylvania.
Okay, great. Hi, Lisa. Are you back?
I hope so. Can you hear me now?
Yes, we can hear you now.
Awesome. I apologize for that. So I'm a sixth grade teacher in Fairfax, Virginia, and I started out with just the Raspberry Pi and thought it was really neat to bring that in my classroom, but then making it move, I found the GoPiGo robot kit and started to play with that and incorporate that into my classroom lessons. And now I'm incorporating the Gigglebot as well, and I help write curriculum for Dexter.
Let's see if I can use this. So just giving an idea of some of our robots here, we've got our flagship robot is the GoPiGo. It's the two-wheeled robot over on your left side. And its brain is a Raspberry Pi, which is a $35 mini computer that gives us sort of the opportunity to do some really amazing high-end stuff and some really simple stuff. So with the GoPiGo, kids can sort of start with block-based robotics, drag and drop programming, and then you can advance up to more advanced programming in Python. The GoPiGo has different ports. You can add sensors. You can add a camera. You can also add servos and 3D printed devices onto it so that you can expand the robot and work within curriculum that either goes step by step or that you can take and sort of customize. We have two rich curriculums for the GoPy-Go, the Go box that introduces coding, and we have one that's based around Mars rover, and sort of students are allowed to do a mission to Mars where they collect data. We built this with McGraw-Hill, and it has some sort of a rich tapestry of additional materials and sort of learning around space. We also have a ton of free projects for the robot as well that you could just hop onto our website at any time and take a look at. You can have kids do sumo bots or jousting with they pop balloons, or do everything if you want to use the camera to identify faces or to take pictures. It's sort of a widely configurable robot. Sort of hard to recommend age groups because a lot of the kids come into classrooms with different backgrounds. But that's one of the really big advantages of the GoPy-Go 3 is that you can use it for kids that sort of come with no knowledge and they can start programming, start learning robotics. You can still challenge students that have some background or some previous knowledge on robotics and coding. It gives you a sort of a wide range tool to sort of use with your students. Our curriculum starts out with a focus for 4th and 5th graders, and it goes all the way up into the university. So sort of used by sort of a wide range of students. The robot in the middle is called the Gigglebot. That's our latest addition to the lineup. This is based on the brain of it is the microbit, which is a really simple and inexpensive microcontroller. And this is sort of provides our 5 minutes to wow experience. You pop the robot out of the box, you put the microbit into it, and you get to programming with drag and drop in make code in less than 5 minutes. Get some LEDs going, use your line follower, and you can sort of your students are off to the races really quickly. And then we through our curriculum and projects, you come back to add different bodies to it, or to give it an add servos and give it an animatronic feel. Fun thing about the Gigglebot is the robot is designed to be built on. We see teachers sort of incorporating the art and social sciences on top of it. They'll add, like I said, they'll add faces, they'll add pipe cleaners, you can add a temperature and humidity sensor or a whole bunch of other sensors, but sort of anything in between that brings art and science to the Gigglebot. There's a curriculum for this as well. It's geared for ages sort of 6 to 14, although again, it's kind of hard to just give it a number, but really depends on your students' strengths and their backgrounds. Either one of these two robots require any installation, so both of them are programmed in the browser and connected to by whatever device you're using. So you don't have to call the IT department to install anything. You connect over Wi-Fi and you're off to the races with it. And finally, our third robot is the Brick Pie, and this is very close to our hearts because we sort of started our company building Lego Mindstorm's sensors and robots. And this also works with the Lego Mindstorm system, which I think a lot of teachers have experience with. It requires a little bit more building and is a little more free-flowing for the classrooms that either have Lego or maybe don't require the same structure. But it's geared towards folks that have the Mindstorms and want to do something a little bit with a more advanced brain. So this uses the Raspberry Pi as a brain, so you can use a camera to do machine vision or to do data science with it. We have a project that we did with Google where you turn the pages of the book with some Legos, and then you take a picture of it, read the text, and it speaks the book out loud to you. So there's sort of an automated book reader. So you can do all sorts of fun stuff with it. And those are our three robots. Next.
Okay, I think we skipped one ahead. So if people, if we're dialing in and looking at this later, I guess the question is for people who are doing first-time robotics programs, what do you consider to be appropriate prerequisites? I know that John and Bambi mentioned some stuff about grade level considerations, and also for embedding this curriculum into the classrooms. Typically, how long do you see this being used as a year-long project or as a sample project, so to speak, in an exploratory fashion? And I'll let my panelists chime in, please.
Bambi, I think you're
you might be on.
muted.
Thank you. I was paying so much attention to Joey's call to mute myself when I wasn't talking. I think that John and Lisa would agree that there's not really any prerequisites to get started with some of the drag and drop programming. The youngest I've ever used a Finch with was a group of 4-year-olds at a local preschool using basically drag and drop arrows to tell their Finch where they wanted it to go. For the Hummingbird, the grade level consideration is more tool use. Most people use glue guns and X-Acto knives to construct their robots, and we don't really feel comfortable recommending that you hand out X-Acto knives to anyone under 9. So most of the people building their own robots from cardboard are doing that with grade 4 and up, roughly. But I think that you can get started with MakeCode or Snap or Scratch quite easily. So you can do a small project just to try it out. Maybe you can get started using only an hour, and then if you have more time, I think you can take it as deep as you want. There's so many different things you can learn in programming and so many different things you can build in different directions. You can take it that we have people get started in really small chunks, but I also see people using the robots throughout the year for multiple projects.
And I definitely agree that there isn't necessarily a prerequisite, particularly with the block programming, because you can start at any level. And if you're like in the elementary school where you have different content areas and you have the students all day long, you can kind of pick and choose which areas to start students out with. So you can do a small project, or you can do a more unit-long project where you're building on something over several times, kind of like the Mars rover project that John mentioned earlier.
So in the elementary grades, do you see students using this as a 2-month, 3-month type of unit, or is it like is it standalone? Because a high school person like myself, we see robots being used as a full year or a half-year course. So I want to make sure I pay attention to what those
Sure.
folks who are not in my venue.
I guess in terms of how we've been using them, we kind of see them just as any other tool in our classroom, like paper, scissors, crayons, markers, whatever else. So instead of maybe making a poster or building something, we're making something that are robots, or we're coding something. And so it really could be, it's not just the robotics, it's learning about space using robotics, or learning about Western expansion through robotics as a tool for that. So I guess it really depends on how it's incorporated. It could be a standalone, or it could be within something else as a shorter piece.
Yeah, I would agree. I've seen people who have them in their classrooms full-time let their students use them a lot. We have a number of people, too, in more rural schools or schools with fewer resources who are using things through a lending library. So maybe they get their robots for a month, and they use them for shorter-term projects during that time, and then they pass them on to the next classroom or the next school. So we have some people who do more intensive units so that they only need the robots for a shorter period of time.
So this is my next question that I put out there. It's a span of multiple grades. I think teachers, like my science director, was a little worried about buying something that was going to be good for a year and then not have use after that. So how do you see these products being used, so to speak, as as you progress? Both of you had mentioned before that they use a Scratch or MakeCode, drag and drop, and then they move on to the text-based languages. It'd be great if you could speak a bit more about that.
You want to go first, John, this time?
Yeah, is my microphone on? Okay, so let's see. I think I talked a little bit about the programming tools that are out there. As far as coming in at an introductory level, you really just need to be able to read, and you can start to use those drag and drop the drag and drop programming. I think that makes it really accessible. On all of our robots, you can program. You can start there, and you can hop along to Python, your first like line-based coding, to Java and to C. So you're starting at the very basic level. You can roll into Python, and then keep on going into more advanced topics like vision processing or machine vision or data science, where you're doing almost like real computer science projects with it. So I think that's kind of key, is there's expandability. When you look at some of the curriculum too, I think Finch takes this approach as well. You've got a balance there between something that a teacher can use, that they need direction, but there are places to go with it that allows you to bring creativity into sort of either use it as a full-on roadmap or to use it as sort of a compass to take you where you want to go. Is that fair, Bambi? You guys sort of have that too, I think, right?
Yeah, I think that makes a lot of sense. We also have a number of people who are getting started with the block-based programming languages, Scratch, Stamp, MakeCode, and you can also use the same robots as you can for yours in Python and Java. So for students who are either starting in high school and maybe an introductory Python course, or who have already done some text-based programming and are ready for something to take that a little further in a text-based. I always recommend for teachers that if you're thinking, I mean, robots are a big investment for most schools. You definitely want something that you're going to be using more than once. So it's really, I think, important to support people as they make more complex programs or build more complex robots so that they can really grow their skills. When I see what schools are doing, I love to see schools, rather than using like one robot, like a different robot each year, to see students really growing their skills with a single set, so that you know they're not covering the same topics all the time, that they're advancing in kind of the concepts that they're understanding and what they're doing with it.
Yeah, and definitely being able to use the robots in different ways, I think is very important. Like you were saying, where they're able to apply it over different spans, or maybe solving the same problem in a different way. So maybe you did block-based programming one year, and then you're getting into text-based, or approaching it with a different methodology is really important. We're using different types of robots for different things. So the Gigglebot, for us, works better for certain types of activities or certain grade levels versus the GoPyGo, where there's assembly required, and they both have strengths, which is fun.
I noticed that all of you were speaking before about how there's a sort of a modular approach to the hardware as well, that you can add sensors and add things to manipulate the environment and to respond to different stimuli. So I think the end is how big your imagination is versus the hardware itself. You can add onto all these products. It seems to give you the versatility to do that kind of stuff as well.
Yeah, I think that's right. I also think, it also depends on what classroom you're bringing it into. So, and what tools you have in that classroom as well. So, we have, for example, a digital making curriculum where you can walk through, do 3D design in Tinkercad, and then if you have a 3D printer, you can add on gears and mechanical devices and have students sort of interact with that 3D software and use the 3D printer to add things onto the robot. Take a servo, and you can turn it into a dump truck, or you can turn it into different working robots that have different manipulators on them. So I think that there are different ways that you can get more mileage out of a robot than what you just see coming right out of the box.
I think that's a great point, and I love the point you're making about robotics can incorporate making as well. I find it really interesting when I work with kids or see their projects. You have some where the physical robot may be pretty simple, and they put so much effort into taking their programming deeper, and you have some who spent so much time on the mechanics and building their vision or built something that's mechanically very deep, and maybe their programming, maybe they don't need that much programming. Maybe all they need to do is turn their motor on for all their gears to do whatever it was that to make their elephants or their rover or whatever it was that they wanted to do. So I find it really fascinating that students can develop deep skills in different ways, either playing to their strengths or sometimes exploring things that they haven't had as much experience with.
And that also plays in just to the soft skills of, working with a team and having to compromise and problem solving. What will work with the materials I have, what are the capabilities of the robot I have, the kit I have, and I think that's been a huge thing as well, is being able to work through those different difficulties, come up with a solution that works for them.
I would agree, and the troubleshooting in a team is different with a robot. Like, do you have a hardware problem? Do you have a building problem? Do you have a software problem? There's a lot of different layers to think through when students are debugging.
So the questions that this revolves around is more of the platform-specific stuff. So I know that people in schools around the country, around the world, are going to have lots of different kinds of hardware and software. So we can get some general ideas about platform support. I know that John and Bambi spoke a little bit about this before, in terms of like what kind of hardware do you have, any kind of limitations you should be worried about, essentially some FAQs.
So we try to support, and from what I was hearing John say earlier, I'm sure the same is true for Dexter, the platforms that schools already have. So we support Chromebooks and tablets and Windows and Mac and Linux computers. So there needs to be a range of things because most classrooms don't have any control over what devices they have to work with. So we need to make sure that they have options. In the last couple of years, we've seen more classrooms that have mainly tablets and Chromebooks. So that's been an area in which we've been developing some more options because we felt like they didn't have enough tools to work with there. For programming languages support, as I said, we offer block-based ones as well as Python and Java. We still have some Finch users out there in processing in C and some other variants as well. But the hardware requirements are really quite low. I think we still have some people out there using their Finches in Windows 7. As far as I know, they still work fine. So you don't necessarily need very fancy hardware to get started.
John?
Yeah, I think Bambi said it all. So, it works on just about everything. So we've seen the explosion of Chromebooks in the classroom over the last few years, so we definitely have to work with that. Windows, Apple, if you've got a tablet, you can use a robot, or you can at least use the GoPi Go 3 on a phone if you want to, but that screen's a little bit smaller really to do much with. So on our robots, all the work is in the browser. It's over Wi-Fi, so there's nothing to install on the computers, which we think is kind of important because the last thing you want to do is have to wrangle with an IT guy or get through your school-specific IT restrictions. You just need a device with browser and Wi-Fi. As far as programming languages go, the graphical stuff, I would defer to Bambi and Lisa on this one, but I think a lot of the graphical stuff sort of pans out to be the same. Like Scratch looks a lot like MakeCode, which probably looks a lot like Blockly and some of the other stuff. But we support MakeCode and Blockly on our robots, so you can do the graphical. Some of our robots also through Scratch. So we'll have Scratch in place for the Gigglebot soon, but everything else runs Scratch as well. And you can move up the ladder to Python or to C, Node.js or Java, depending on how advanced you want to go. I'm not sure. So I think that Amy and Lisa, you guys know this better than I do, but I think the APCS is based off of Java. Is that right? Or do you typically teach that with Java?
Principals can use other things as well. I'm sorry, Neil. You go ahead.
No, we have. Okay. If you're going to do APCSA, it's going to be a Java-based course. Essentially, like equivalent to a first-year computer science programming language would be at a college or university. So it is Java. In CSP, it does not require you to use any kind of thing. You use mobile CSP, we can use App Inventor, any Python, any other language. If you're using Arduinos, you can use a C language. So it really does not force you to. And I think that's one of the things that my students have seen is that when you take computer science, it's not a language course as much as it is a discipline that requires you to learn different languages for different things. If I'm doing web design, or if I'm doing databases, or if I'm doing engineering, I'm going to use a different language that's appropriate for the job. I also teach my kids Linux, so they know the operating systems. If they do, hope to be teaching some courses in cyber. So there's a really the best thing about computer science is there's no limit and there's no just you're not boxed into anything. There's a lot of different things you can do. And having the opportunity to do different languages and different operating systems is just part of what we have to learn.
So Neil, if you're teaching a class of say freshmen and sophomore in high school that are going to be funneled up to that CSA program the next year, you'd feel comfortable teaching them Python alongside
typically
Java or any sort of
in my experience is when we start the kids with Scratch or Snap or other kind of block-based code. I've been using MakeCode when I got my first BBC microbit a couple of years at the CSTA conference, and I think that's a great platform because as it was said before, you can get 5 minutes to get something working, and you don't have to worry about the syntax issues. When I started I was actually using the Finch robots, but I first started teaching my kids Python because the Scratch interface, they said they got a little, I guess with high school kids, they get a little tired of it and want to do something a bit more advanced. So Python would be my first personal preference, be the first text-based language I would teach my students. And then they go to Java with the object-oriented stuff. So that's pretty much a high school level. What my director of science is saying, we do an engineering robotics program where they're using the Bebot and the Parallax, which is more of a wiring of breadboard kind of stuff. And she said that's great for kids who want to do engineering, but we'd like to do more of a programming course, so a class where the robots become the tool to learn programming versus a tool to learn electronics. So I think it's great that robotics is a platform that supports both those needs. I'm in a co-taught class where I'm working with a guy with a professional engineering degree, and I'm the computer science person. So he knows how to read the resistors and rheostats and all the other electronics, and I know how to read the code. So it's sort of a very nice to have that kind of blended approach to what's going on. So Lisa, what are you using for text-based languages at the elementary levels?
It really depends on the students. We've gotten into Python a little bit, and then now with the microbits, going between MakeCode and JavaScript, just started out with that. It's really, again, based on the students' understanding previously and building off of that and into their interests. Even trying to get them outside of robotics, getting into Python using Minecraft, and then kind of bringing them back into it using the robots. But that's been something that a lot of my students are itching for. They've kind of gotten a lot of exposure to the block-based coding through things like Hour of Code, and they've seen it before, and they're looking for something different. And that's really been nice, and the flexibility in different languages. Like you're saying, they're all kind of similar once you get the hang of it. Blockly and Scratch and MakeCode, they have a lot of similarities. And so once they see those, they're more flexible in their thinking.
I do find it really interesting because you see students with such a range of experience. Like Lisa's students, because they've had a lot of experience with block-based coding, are ready to try text-based in 6th grade, whereas I've taught a high school CS class where the girls came in and they'd never had any coding. So like Neil, I started with the block-based. You want people to have that early success so that they can understand those concepts before they get bogged down in like, I didn't capitalize this, and suddenly everything went all to heck. So, but I think we're at an interesting juncture where you have some high schoolers who've been coding for years and some who've never done anything at all. You really have to know your students to figure out what they're ready for.
Absolutely, and it's also been helpful. I teach an inclusion classroom, so students with decoding difficulties or encoding difficulties, taking away some of the struggles they have, where you know the color of the block, or you can read the headings. You can kind of get to the right area that you need. You don't have to remember the spelling. You don't have to remember exactly everything perfectly the first time. You can get your robot moving. You can get things happening before you're worried about those syntax errors and really picking through something.
Well, great. I'm happy to go to our next slide. One of the things that I remember, and I will call up both Bambi and Lisa, when I first met Bambi, she was showing her robots with videos of the kids doing Romeo and Juliet. And I said, this is not what I think about of coding. It was like, oh, here's robots being used to teach in English language arts. And I believe at last year's CSTA conference in Omaha, I went to Lisa's section when she was talking about how I'm using robots with kids to learn about westward expansion. She showed videos of maps. So I got really excited. I said, oh, good, they're both going to be here, and they can both talk about how we can use robots that are not in a quote-unquote a STEM discipline, but in liberal arts and other types of things. So I'd like to have them really expand on how they're seeing robots being used in those kind of environments. And if they have any personal anecdotes or something they said, wow, that's really cool, I never would have thought about that, and let's share it with our listeners. Bambi, can't hear you.
Sorry. Sorry. Yeah, Robot Shakespeare is one of my all-time favorites. Along with its companion, Robot Poetry, we've had a number of, I've seen a number of teachers do that as well. So the idea is that students really focus on a single scene or a single poem. They have to read it repeatedly and figure out how to construct a robotic diorama based around those ideas. And this is an important part, they then have to present their robot and show it off and argue for their design decisions in the context of the symbolism in the scene or the poem that they chose. And what I love about it is that the teacher, a woman named Sue Mellon, who works in a school outside Pittsburgh, specifically chose robotics for those topics, poetry and Shakespeare, because they are the ones where students have to read the same thing over and over to really understand it. So these are 8th graders in Shakespeare. It's their first experience with Shakespeare or that type of language. And she uses the robotics to make sure they stay engaged with one passage long enough that they've read it enough times that they actually understand it. So I loved her pedagogical reason for why she chose robotics for that particular thing. And I also love that as an engineer, I would never have thought of it. I just love that it's so different. And another one that I really love in a very different field is one, he was a PE teacher, but he was teaching health, who did robotic models of the elbow. And what I love about it is that students were not allowed to put the motor right under the elbow and make it move back and forth. They had to use 2 motors to model how the muscles actually worked. So how your biceps and your triceps work is that as you bend your arm, your triceps have to let go while your biceps get shorter. So they had to model that motion rather than just creating something that moved. So again, I really liked how that teacher used the robotic part to bring out the part in their field that they were trying to teach.
And we've used our robots in a similar fashion. We're trying to get the students to really dive in on something. And as Neil pointed out, we do, one of the things we use them for is maps quite often. One of my favorite lessons is one about westward expansion, and the students really like the Oregon Trail games that I played for a while, and it's, they still enjoy that. However, we made a huge map on the floor, and their robots were then wagons that they had to load up with materials, and we created a whole game around it. And then we were just reinforcing that map skill over and over and over again, where they just learned about the different territories and traveling and obstacles. So pulling in all those standards that we had to hit on, and then even incorporating reading and writing. My students didn't like my directions or my game rules, and so I offered them the opportunity to rewrite them, and they created a whole new avenue onto this game. Again, still incorporating the programming and the robotics into it, but then getting into different types of writing, working on functional text, and how to convey your point clearly. And it really excited them about learning. We've also done in other subject areas where they, for like American Indians, but just changing the map on the floor for that. Another one that we've really enjoyed is similar to the Romeo and Juliet one, but students have to create a story by coding it. So looking at plot structure and breaking down plot structure, and what would it look like if your robot is now the character. And it turned out to have these intense stories where we had students battling out, and so their stories overlapped. We had Harry Potter scenes with wands and everything going, but they were able to break down that plot structure and show, okay, rising action, things are getting more tense, what's going to be happening with your robots, that climax, that's the most intense moment. How do you show that visually, and then how do you show that in your story?
That's really kind of cool stuff. So this is where I'd like to have you share some of the ways of, if you've developed some of these things. I know we have an addendum with links given to us by John and Lisa and Bambi that have, speak if you can, a bit more about the resources, curriculum, professional development, and also I know that your companies also have ways to evaluate products.
Sure. On Dexter Industries, everybody is welcome to come look at the curriculum that we have and the different projects. They're all up on our website. And if you look at the top bar while you're there, there's a free teacher trial. So if you haven't used these in your classroom and you want to give them a shot, we'll send you a robot for free for 45 days, and you can test it out and see if it fits into what you're working on. And that's probably the best way to figure out how you feel about it. Just give it a shot.
Like John said, most of our curricula at Birdbrain are also available on the website. For the Finch and the Hummingbird, we kind of divided into two parts. They're like the how to do the basics. You can imagine for the Hummingbird, before you build something cool, everybody needs to know how their servo works or how to turn on the LED. So we kind of have basic lessons for getting started, and then we have examples of projects that teachers have done that we've documented in their classrooms, such as Robot Shakespeare and a number of the others. So we kind of have them divided into projects that you can do once you have some basics and materials to help you get started. We do offer professional development. We have several trainers. So if you're at a conference, a lot of times they'll do workshops based around the conference, or occasionally we'll travel with the school district. It's requested training. And we will also loan you test products. You can test out the Hummingbird or the Finch. For the Finch, we also have a loan program. So if you're looking to run a summer program or something this summer, I know Neil was one of our loan program recipients in the past. You can borrow a flock of about 20 robots for free if you're planning to use them with kids. So there's I've added application information for that to the document as well.
That was very cool. It was great way. And after I had them for my trial period, I actually drove into another school, K through 8 school, about a few miles away, and they were able to have some fun. So again, I think it's really important that we hear from other teachers that that people have been using these and have your samples of curricula that you can just sort of pick up and go with, which I think is really nice that you have those available on your website and also in the addendum to this presentation. We're going to encourage everybody who's a member, but I would love to have anybody have any questions from the audience.
Please feel free to type them into the chat, and we can voice them over so everyone can hear them. And yeah.
And I'm going to encourage everybody to join the CS4 All Teachers. I write a blog on various different projects. Question is for Megan for John. You said that you enjoy coming into classrooms. Would you model your products, and what would you do when you go into a classroom?
Oh, that's a great question. So I think when I started Dexter Industries, I hadn't been in a classroom, or I hadn't been in a high school or middle school for 15 years or so. So most of it is actually to talk to teachers and to see how they're using it, what's working for them and what's not, and just to have an idea of what's going on in the classroom. So sometimes, especially in the Virginia area, I'll go out and help somebody get set up for the opportunity just to sort of observe, like classroom observe what they're doing and what's working for them and what's not, and sort of brainstorm about ideas. So when I said I go into the classroom, I definitely don't go in to teach, but I just try
I'm
to
not
go in
a
to
computer
learn.
science
Yeah.
person by training. I was sort of self-taught, and I was licensed in special ed. So it was kind of cool for me to get into computer science at teaching using robots. So what can I ask, Lisa, how did you get involved with using robots?
I kind of fell into it. I randomly came across the Raspberry Pi and thought it was really cool. Got one in my classroom. My kids got excited. We tried to build our own robots and failed several times. And then we found the GoPiGo kit, and I brought it in my classroom and spent lunches with my students building it and programming it. And it just kind of turned into something really as an integral part of my classroom. So I'm completely learning as I go. Dexter has been along there the whole way, answering and supporting all my questions. So, yeah, it's been a learning curve, but I'm definitely not trained in it at all. I just went to school to be a teacher for elementary and middle school.
Bambi, does your company have people who become sort of certified as teachers in your technology?
At this time, I think we've been considering not certified. We do have people who have been trained to be trainers, so we don't really have a certificate process per se, but we have had, particularly if a district has, for instance, like a district has made a large investment, then of course we want them to have people on the ground who can do trainings on a continual basis. So we've trained some people like that, and there are a few people who've been trained who are in different parts of the country. For a while there, it was just me and Tom, and so we couldn't travel. We are very fortunate enough now to have several trainers who can travel to a lot of places we can't get to otherwise. But we also have people who've been through, there's kind of like a regular learn to use your robots training, and then if you're going to train other people, there's kind of some more in-depth information, more information on troubleshooting or the types of things that might happen that we go into.
So how does one become a Dexpert, John?
Reach out to us. So if you are interested in using our products, or if you have a fun application, we want to talk to you, and then we're really open to how we collaborate with both teachers and engineers. So um, we don't have there's no defined ritual for becoming a Dexpert yet. It's a exclusive priesthood, but there's no
So,
ritual.
John, there's a question from Bob. He said, "Did not see the Gigglebot on the website from
Yeah.
Dexter." So,
Right. So we have a separate website for the Gigglebot. It is gigglebot.io, and if you go there, you'll see the Gigglebot. There's a link to it, but it's probably not well positioned on our website. Yeah.
I see a few more people typing in the chat box, and so I want to give them a moment to finish putting in their questions.
we're closed.
Oh,
Maybe are you guys going to get a
closed the whole
snow
week
day
the other
tomorrow?
day. So,
We're closed all week. Well, we're closed all week because it's President's Week here in Massachusetts. So, all of my friends are going to Paris, or they're going to South Florida, or they're going somewhere other than Massachusetts, or they're going skiing. I don't ski, so I'm staying put. So we have a question from Teresa. Somebody wants to answer that. It's about the Go Pi Go with the engineers with the Raspberry Pi.
Yeah, it's very cool.
Thank you for your excitement, Lisa.
Brian has a question. Are there notable problem areas in robotics that teachers and students are finding difficult to overcome?
that is a great question. I think the biggest problem for a lot of teachers is just that it, particularly for K to 8 teachers, if you, like Neil, don't have any experience in robotics before, it seems like it's going to be really hard and possibly scary. Or maybe you'll get electrocuted or something horrible will happen. So I think really the first barrier is just giving it a try. A lot of people, when they try it, the first thing I hear out of their mouth is, that wasn't nearly as hard as I thought it would be. Sometimes people who experienced programming maybe 30 years ago before any drag and drop programming don't realize that it can be a lot easier to get started now.
I think that it's also, again, on the teachers, sorry.
Go ahead, Lisa.
Sure. I think also just teachers not thinking that there's time for it. And if you think about the robotics as just another tool, a different tool, maybe something that you're not completely comfortable with, but it's something new and you're learning alongside your students, then there is time for it. You have time for other bigger projects that you do. This is no different. And also just maybe not having all the answers. Teachers who are comfortable with other subject areas, maybe not knowing all the answers for something, like let's go research that on your own, it's okay. But when it comes to robotics and programming, if they don't feel solid in it and they don't have that background, it's a lot scarier to stand up in front of the class and say, you know what, I'm not sure. But having that confidence that you can learn alongside your students with it.
Yeah, I think one of the things I've had with my students, all the kids are they don't wake up with robots underneath their Christmas tree.
The greatest.
So for them to actually try something mechanical and have something that they program versus something they just manipulate on a screen, moving pixels around, is a very different experience. Just getting the motors calibrated so it goes straight. Programming can be a very, I say initially a very frustrating experience until you get used to saying you have to do things to get good at it, and it's not something that they found. Wasn't just turn it on and click 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 with a remote control. It's a very different type of experience. We have another question from Teresa. A question about buy-in for incorporating robots and how she feels so alone.
So we've had a number of people use the loan program for that. Specifically, it's certainly not why we do it, but if people are able to borrow some through a lending library or through the loan program and give it a try, and then show their administration or sometimes their school board, depending on who makes these decisions. I've seen people even have their kids give the presentations. A lot of times if they see the engagement or they see what they're getting out of it, it becomes an easier decision. Because I respect that the school boards and every administration, there's a lot of things they need to spend money on, and they should consider all of those decisions carefully. But sometimes being able to show what you're hoping the students will get out of it, as well as how you plan to use it in your classroom or connect it to other curricular areas, can be helpful.
I definitely agree, and that's, I mean, getting the lone kid or getting one or two to try out in your classroom and then inviting administration down to see the engagement, to see the connections, and then being able to use the kits over multiple years. They're not disposable. You can use them again. You can use them in multiple subject areas, and then you can add on. So maybe this year you're just using the regular kit, then you're adding on different sensors and servos, and you're making it, you're making more with it.
And definitely you can share them between, we have a lot of schools who essentially run an internal lending library. So English, 8th grade English has them in September, and 7th grade social studies has them in October. So recognizing that you can use the same kit in multiple classrooms. You don't necessarily have to invest. While I'm sure everybody would love to have robots in their classroom, you can certainly have a successful program without that level of investment.
And I also want to show people the last slide. I have everybody's Twitter handle. It's worth following these people because they're doing some really cool stuff. Also their main website, and of course myself on CS4 All Teachers, as well as our host in the back end of everything, Joey Wilson.
I just wanted to thank everyone for joining the webinar. I did put a link to a survey in the chat box, and we really just, if you could take just 2 minutes and fill that out before you close your computers for the day, that would be wonderful. We really appreciate you taking the time out of your day, especially at the end of the school day, to come in and to learn. We know that you have a lot of different restraints and sort of commitments that you have to go to, and we appreciate you spending your evening with us. Thank you so much to our panelists, Lisa, John, and Bambi. We really appreciate you taking the time to do this. And Neil, thank you so much for hosting this. In addition to just this webinar, we are recording it, and it will be available on the website, I believe, starting tomorrow. In addition to, Neil has created this addendum with resources that you will have access to using the same link that you used to get here. It'll have everything just sort of stored right there, and we will put that up. So with that, please let us know if you have additional questions. You've got a way to get in touch with me. You've got a way to get in touch with everyone else that's on here. These slides will be available along with the presentation and these other resources. And I hope you all have a wonderful evening. Take care, everyone.